Inheritance is a way to share common attributes and functions across a subset of related classes. So a very simple example of that is apples and oranges are both fruit. Fruit is what is commonly called as the parent or base class, and apples and oranges derive from that class. So as a base class, fruit can define a few variables for the apples and oranges. So fruit has a shape, it has a color and a size, and that's both represented through apples and oranges, as oranges are orange, apples are red. They have a particular size, they have a very defined shape. So let's get stuck into our example. Now, the first thing I need to do is our first person blueprint projectile by default does not apply any damage, and we need to do that. So I'm going to navigate to our blueprints folder in the first person blueprint content, and I'm going to open our first person projectile. Now, after the add impulse node, we need to add an apply damage node. And we need to give it a particular amount. Doesn't need to be anything special, just as long as it's greater than 0. And we need to supply it with the actor that gets damaged. And on our event hit node over here, we can just drag the other node and connect it up there, like so. And that's all we need to do to complete this example. So we can save that and close it. Now I'm going to add a new blueprint actor and call it blueprint base. And I'm going to open it up. Next I'm going to add a new scene component, call it root, add that as the default root. And next I'm going to add a new cube component. And we can just call that cube static mesh or something like that. And compile. Next I'm going to set it to simulate physics, compile, and I'm going to add it to our scene. And if I play that there, it just simply simulates and we can interact with it. But that's not very interesting. So I'm going to use inheritance to add functionality to our base cube, if you want to call it. So what I'm going to do is I'm going to create a child blueprint of this class, and I'm going to call it random size. Now in our event graph, I'm going to delete our default nodes, and I'm going to call the event any damage node here, like so. Now, because this is an inherited actor of our base, I need to add the parent function. Because if our any damage gets called in our base class, and it does any particular sort of logic that we want to cascade down into our derived classes, we need to call the parent version of that function first. Next, I'm going to get our cube static mesh. So I'm going to call cube static mesh, and I'm going to set its world scale to a random value. I'm going to split the vector there, and I'm going to call random float in range. And I'm going to drag those onto all three variables. Now we can set a hard value here, but we want to use a variable to control that so that we can set it later. And I'm going to get a min size and a max size variable. And they're just going to be floats. And we can just drag and drop those. Before we go any further, we need to compile and set their default values. So for our minimum size, I'm just going to set 0.5 and 1.5 for our maximum size. And compile. Next, I'm going to go back and add that to our scene. And when we hit play, you can see that it's now changing size. Our base actor, however, because it hasn't got that functionality, it does nothing. But our random size inherited actor uses that functionality when it takes damage. And we can extend that further. So if I create a child of our random size actor and call it random color, for example, and come over into our event graph, delete those nodes, we will do the same and call the event any damage node. And again, because it's an inherited actor, we need to call the parent version of that function if we want to retain the logic that occurs in the parent class. Now, to set up random colors, I need to create a new material, and I'm just going to call it material random color. Oops. Random color. And this isn't going to be very difficult. We're just going to add a new vector parameter, which just allows us to set its value in a blueprint. And I'm going to call it base color. And that's a very important step. You need to give it a particular parameter name for it to work. And I'm just going to save that. Next, in our construction script, I'm going to get our cube static mesh, and I'm going to call the create dynamic material instance node. And what this does is it creates a version of the current material that is applied to this static mesh and makes it into a dynamic instance so that you can access the parameters that are on that material and we can change their values. So to make it easier for ourselves, I'm going to promote the return value to a variable and call it dynamic instance material. And I'm going to come back to our event graph. And then now I'm going to use the dynamic material instance to set a vector parameter. Now if you remember in our material, when we created our material, we created a vector parameter and used that as our base color, which we need to set in our parameter name. Base color. And I'm going to hook that up there. So at the moment, when our random sized random color actor receives damage, it's going to set the vector parameter of its material to black at the moment, but we want that to be random. So I'm going to drag off of our color variable and I'm going to call make color. And we just need to do the same because these are float variables. We need to do the same for our random size. We need to get our float in range, a random float in range. And I'm going to set the max to 1 and we can copy and paste it 2 more times and connect those up to the RG and B variables there. Now that should take care of our logic, but if we drag our new box into the scene and press play, you'll notice that it does change size, but it doesn't change color. It's inherited the size changing logic, but we forgot to set the material on that particular actor. Now we could set it on the inherited version, or we could set it on the base. And if we set it on the base, it's not going to change for our base or our random size actors because they don't have the logic to change it. But it will for our random size and random color actor. So our base does nothing. Our random size changes size. Now random size and random color changes both. Because it not only has it inherited from our base, it's also inherited from our random size. And it's implementing its own color changing logic. So if we want to go one more step further, create a new child of our random size and random color, we can call this one random shape. We open this up in the editor and we call the any damage event again, and we need to add the parent version. Get our cube static mesh, and we can call the set static mesh node, and we want to give it a new static mesh. So what we can do is add a new variable, call that shapes, change its variable type to static mesh, and set it as an array. And if I get a particular index from that array, and we want to use a random index, so let's get our length of our array, subtract 1 from it, because our array indices start at 0, but our length returns how many elements are in that array. We need to use the length minus 1 to get the last index. So if we go random integer in range, our last index will be our maximum for our random range. And we can hook that up there. Now if we compile that, add it into our scene, we need to set the shapes variable to editable, There it is in the details panel, and we can add a few different shapes for it to change to. Now if we press play, our base actor doesn't do anything. Our random size actor changes size when it receives damage. Our random size random color changes color also. And our random size random color random shape will change shape, color and its size when it receives damage. Now, the good thing about inheritance is that we can set these variables on each instance. So you'll see that our min size and max size for our scale changing logic, because it's only implemented in our random size actor, it does not show up on our base actor. But if we click on our instances for our derived classes, you'll see that the min size and max size will now show up because they've inherited those attributes, and we can change them on those instances. So if we bump that up a little bit, I want to bump that up a little bit more, and that maybe a little bit more. And if we press play now, oop, bit too big, very, very big. But you get the picture. So just to recap, inheritance allows us to share attributes and functions across derived classes. And that's at the essence of OOP programming, or object-oriented programming. It's a very powerful concept, and it can be applied to a wide variety of problems. And that will do it for this tutorial. Thanks for watching.